Okay, welcome to this Packet Tracer network demo. As you can see from this diagram here, we will be dealing with 4 routers, and they will be Cisco 2911 routers, 2 layer 3 switches, and then there's going to be 7 layer 2 switches in the Big Ten West, 1 switch in the Big Ten server, we'll call it network, in the pink there, and then on the far right in the East Division, we will have 7 more switches. Each switch corresponds to a particular team and a particular VLAN, which is associated with that team. Now, you notice at the top, that top router, he's basically the central hub router. He's going to be the router that's responsible for really connecting everyone together, because there's 3 other routers which are connected to the other 3. Let's say they're buildings. Let's say there's a Big Ten West building. There's a server building with all the servers that Big Ten West and Big Ten East can access. And then you have your Big Ten East building. So let's say that top router there, the very top, is the central router that connects all 3 buildings, the wide area network router, if you will. And you notice how each router has at least a couple NICs, network interface cards. Again, the top router has 3 of them because it's connecting to 3 routers. The other routers only have 2. And each one has an IP address. So in the sort of wide area network portion of the address space, you have 10.0.0.0, 10.0.1.0, and 10.0.2.0. But then all the Big Ten conference networks will be in the 172.16.something range. The server network will be 172.16.0.0. The Big Ten West, which is going to be divided up into a bunch of VLANs, is 172.16.1.0 through .7.0 for the 7 teams, and as well on the east side you have 7 more VLANs or subnetworks or whatever you want to call them. They're distinct networks from each other. Let's say they're on different floors, right? So you have the Big Ten West building, and there's 7 floors, and each floor has its own switch, and they're all connected to a big layer 3 switch. Let's just imagine that scenario, okay? So yeah, this is our diagram. This will kind of tell us almost everything we need to know as we're working through this Packet Tracer lab. And one thing to note here is there's 2 kind of special network interface cards. One on the Big Ten West Division router and one on the Big Ten East Division router. I put a little star there. So these network interface cards are connected to the layer 3 switches via a trunk port that will be configured with the 7 IP addresses, 1 for each VLAN or 1 for each team. So that is something to keep in mind, because as we deal with these VLANs, that those 2 network interface cards are going to be configured a little bit differently from the other ones as we're dealing with trunk ports and so forth. Okay, moving on, let's do a quick little overview of the commands we're going to be using for the Cisco routers and switches, and just the steps that we're going to go through. They don't necessarily have to be in this order. This is just the way I set it up. In step 1, we're going to open the port connections on all routers, all the 4 routers, and specify the clock rate on the serial DCE port only. So we're going to be installing a little module onto the Cisco routers that allow us to use serial connections between the routers, just to simulate basically a wide area network connection. Now, in the real world, you'd see fiber optics or Ethernet or whatever, but just for here, we're going to be doing serial. But keep in mind that for serial DCE modules, you need to specify a clock rate for the DCE side, so that main top router with the 3 network interface cards that connects all of the other routers together, we specify a clock rate on there. So I put it an asterisk, but the other ones you just say interface, and then in this example, SE for serial 000. It could be gig 000, gig 100. You'll see as we go through the Packet Tracer lab. Then enter, and then the next line will be no SH for no shutdown. And then, like I said, clock rate for just that top router. And also keep in mind that every router and switch that you connect in, that you remote into, you need to first enable and then configure terminal commands. And then when you're done with each interface, you say EX for exit. So keep that in mind. You'll see that again as we actually start the Packet Tracer demo. Okay, step 2 is going to be configure each layer 2 switch for virtual local area networks. So here we started with the top routers, and then we're moving down to the layer 2 switches, and if you remember there were 15 of them total. But here we're just doing the 14 for the VLANs, because remember the server network did not have any VLANs. It just had a layer 2 switch. So we're going to go to the Big 10 West and then Big 10 East and configure all of the layer 2 switches for VLANs. It's very repetitive. So you just go into the command line interface, enable, configure terminal, and then you say int for interface, of course, range, and then because it's a 24 port switch and we're using all 24 ports for one virtual local area network that will connect into the layer 3 switch, we will say FA0/1-24, just so we don't have to do every single interface one after another. We can just group them together. And then we say switch port mode access, and then we say switch port access VLAN, and then whatever VLAN you're configuring. So VLAN 10 is going to be our first VLAN. So you enter that command, and you say exit for exit, and then you specify a new, or I'm sorry, you just say exit, and then you can do right for to save the configuration. And then you just go down the line, each layer 2 switch, just enter those commands. However, that last number, so VLAN 10, the next one will be VLAN 20, 30, 40, all the way up to 140, because there are 14 VLANs total. It's very repetitive. Step 3, configure layer 3 switches for VLANs, and this is almost identical to the previous step. So each layer 3 switch has 7 layer 2 switches coming into it. So instead of in the previous step where we did one command or one group of commands per switch, here we do the commands for each interface. So you get into the command line interface for the layer 3 switch, enable, configure terminal, and then int, and then whatever the interface is. In this case, I put gig 1/0/2. And then you say switch port mode access, switch port access VLAN, and then whatever VLAN you're configuring for that interface. And then you just go in order. And then you say exit, and then int gig 103, switch port mode access, switch port access VLAN 20, and then exit, and then int gig 1/0/4, enter, and you just keep going in order. Step 3.5, because we're still going to be on the layer 3 switch. We're going to activate trunk ports on the layer 3 switches. Now, you specify the interface. It'll be different from the interfaces that you did the VLANs for, right? It'll be a different interface number. I think in the lab it's going to be interface gig 101. And then you say just very simply switch port mode and then trunk. And then exit, do write to write the configuration, save it. That's pretty simple. Step 4, you're going to assign IP addresses to all network interface cards on all 4 routers. Remember our first diagram there? Each router has several network interface cards, And then those ones that are connected via the trunk port to the layer 3 switch will be configured slightly differently with sub-interfaces for each VLAN. So the regular commands are just int and then whatever interface you're dealing with, in this case serial 000, enter. And then the next line is IP address, say 10.0.0.1, and then you just put a space and then do the subnet mask. And I'm doing /24 subnet masks for everything just to keep things simple so I don't make an error. So 255.255.255.0. And then for when you're configuring the sub interfaces, you're going to specify the interface, but you're going to put a dot and then the VLAN number. So in this case, int gig 0/0 dot and then 10, which is the first VLAN we'll be configuring. Encapsulation.1q 10, which matches that number in the first command. Then you enter that command, and then the third command is IP address, and then 172.16.1.1, and then the subnet mask. So each VLAN, the VLANs go by tens, but the IP addresses go by ones. So 10 is correlates to .1, 20.2, and so forth, all the way on up to .140, because there's 14. So 140 will correspond to 172.16.14.1, etc. Just goes in order, very sequentially. Step 5, then we are going to enable DHCP on the routers that will provide that service. In this case, only the 2 routers connected to the layer 3 switchers will be providing the DHCP service to the clients on the networks, right, that are, so each team has its own network, and say there's 20 computers for each team, they would be receiving DHCP from the router. So we just remote into the router, say enable configure terminal, of course, service DHCP. Now you don't need to say service DHCP for every DHCP pool, because there will be 7 pools, right, for each router, the west and the east router. So you say service DHCP, and then the loop begins where you say IP DHCP pool, and then the name of the pool. In this case, the first one is Illinois. Enter. Next command is network, and then in this case, the network ID is 172.16.1.0, because that corresponds with VLAN 10, which is the Illinois team's VLAN. And then, of course, the subnet mask. Enter. Next line is default -router, and then for the Illinois network, it's 172.16.1.1. And then DNS servers, not really important, but 172.16.1.1 or whatever it is. We're not really setting up DNS in this lab, so it's not that important, but whatever. And then after that, you enable the routing protocol on all 4 routers. So you just get to the command line interface, say router RIP, because that's the protocol, RIP, and then you say version 2 in this case, that's what version we'll be using. And then all of the networks that that router will be connected to, and will pass traffic from one network to the other. So the Big 10 East and Big 10 West routers will have more. You'll list all of the networks, like 172.16.1 through 7 for Big 10 West and 8 through 14 for Big 10 East, and you just network and then IP address, and then the IP, right? Network IP. So some routers have 8, some only have 3. Here's some tips as we're working through this. Try to visualize connecting to physical switches and routers via console cables, because in Packet Tracer you're just kind of clicking on stuff and it's all very easy. And once you click on a router or switch, you can just go right into the command line interface. But in actuality, you have to have a console cable and hook them up to from your computer or whatever you're using to either a terminal server which is connected to the router or switch, or directly to the router or switch. And in that case, you would need a terminal emulator software tool like PuTTY. Most people are familiar with PuTTY. That's what many people use these days. So keep that in mind. Try to visualize it, because this lab is it's got a very logical view. It's not really, there is a physical view, but we're just dealing the logical view today. Also, you can make this project a little simpler by just limiting the layer 3 switches to have two VLANs, and then you can just omit the server network altogether and just focus on setting up VLANs, trunk ports, and the sub interfaces. Configuring all 14 VLANs is repetitive, as you will see. So if you can do 2 on each side, then it stands to reason that you can do more. And also learn the equipment. So we're going to be using Cisco 2911 router, a Cisco 2960 layer 2 switch, and a Cisco 3650 layer 3 switch. So here on the top left is the 2911 router, but on the back you can see it's got some the ports that you connect to, and I circled the console port and enlarged the image, and it conveniently says console so that you can plug your console cable. In this case, I have a light blue colored console cable there. One end is USB, the other end is RJ45. The USB side would, of course, connect into your laptop, and then the RJ45 connector would connect into that console port labeled for your convenience. And the 2960 switch also has a port labeled for console, and it looks like you can do USB mini as well. And of course, use a terminal server or a terminal emulator software tool like PuTTY to access the command line interface of the routers and switches. And here's some more. There's the layer 3 switch. You notice it's got a bunch of just your standard Ethernet ports. But then to the right of that, you've got like 4, they're called uplink ports. And on this switch, the RJ45 console port is actually on the other side, and I circled it there in red and enlarged it. So that's where you would plug in the RJ45 console to on this particular switch. And on the front there was a USB console port too. So just learn these devices. Go on to Google and just type in the Cisco 3650 layer 3 switch, and you will find manuals and all sorts of information about these things. Now, here are some pictures taken directly from Packet Tracer. They have little looks like cartoon images of the routers and switches. So look at those as well. So on the top left there, you have the 2911 router. And then in Packet Tracer, when you connect routers and stuff to each other, to switches, it'll pop up a menu of the available ports. So as you can see to the right of there, there's a menu with 5 ports. You have auxiliary console, and then gigabit Ethernet 0/0, 0/1, and 0/2. The gigabit Ethernet ports have like a yellow label tab next to them. The console port, it's got a light blue label. The auxiliary one has like a black tab. And then you notice there that there's a couple of USB ports which don't appear on the menu. So just start asking questions like that, like how come those aren't on the menu? And then below that, I've got the 3650 layer 3 switch with a little diagram from the official Cisco manual. And then you can see there that all of those 24 Ethernet ports, according to the manual, are 10/100/1000 PoE, which is power over Ethernet ports. But the 4 ports to the right of that are called uplink ports. So that's something to keep in mind. Learn the ports for the devices. There's also a USB mini Type B console port, some status LEDs, a mode button, USB Type A storage port. So just start doing some research, figure out what those do. And you notice I have the menu too as well on the far right for that layer 3 switch. You notice it has all the gigabit Ethernet ports on there, the USB console port and the console port, but it doesn't have the uplink ports. So, just start asking questions. Why aren't the uplink ports in the menu? And like, how do you get them to show up in the menu? And on the bottom there, you've got your layer 2 2960 switch, and that's just got 24 ports, fast Ethernet ports, and then it has 2 ports to the right. You notice in orange there on the menu. They're the gigabit Ethernet ports. So these ports are maybe to connect to higher bandwidth devices like a file server or a router or something, as opposed to the regular fast Ethernet ports, which you would connect to computers and printers. So learn the equipment. All right, so let's get started. Let's add our routers according to our diagram. Just refer to that diagram throughout. It'll all match up with that. Layer 3 switch, layer 2 switch. Remember, we got 7 on each side. 1 there for that server network, and then 7 more for, in this case, the Big Ten East networks. And then we're going to I'm just going to add 1 PC to each switch. Try to imagine, though, that each switch has like 20 PCs, right? And a printer or something. Because otherwise you wouldn't even need VLANs if you're only using 1 PC per switch. Now we're going to add the modules, the serial modules to the routers. You just go into double click them, click the routers, click off, add the HWIC2T to the slots there. Pretty straightforward. Turn it back on. Now we're going to add power supplies to the layer 3 switches. Now we're going to connect serial cables to the ports. And I'm just using the lightning bolt icon to connect all of the routers and all of the switches to the PCs and whatnot. So for the serial cables, though, you click that red icon with the clock on it, and then you just connect, and then you just enter a serial port, right? If you try to do the gigabit Ethernet ports, it won't let you, of course, because they're serial cables. So it's pretty straightforward. You notice how they have clocks on them when you hover over them. So each one, serial 00010. You need to keep track of what the interface is labeled as. So for those, it's serial. But for the layer 3 switches, it'll be gigabit and stuff. So now we're going into each router, and we're going to say enable configure T for configure terminal, int SE000, and we're going to say no SH for no shutdown. And then I'm going to establish a clock rate of 64,000 for all 3 interfaces on that top main router there. Again, int SE001 for the other interface, no shut, and then clock rate 64,000. Exit to enter the new interface, int SE, I think it was 101 or something, or 010. No SH. Also, if put those serial modules in the routers in the same spots I did. If you did not, if you type in the same commands as I do, it won't work, because if you put them in a different slot, it's like different. It'd be int SE2/0/1 or something. So keep that in mind. Now I'm just gonna zoom through this because it's all the same. You just click on the router, whatever interface you're configuring, you say no shut for it, no shutdown. And then do write, DOWR for do write. It saves everything. So yeah, we're going to go to the layer 2 switches next and go to the CLI. Try to imagine you're actually doing it yourself with physical cables, but we're in the CLI. Enable conft int range, because we're doing all 24 ports, FA0/1-24. So FA0/1, FA0/2, all the way up to 24. They're all included. Switch port mode access, switch port access, VLAN, and then the first one is 10. It says VLAN does not exist, creating VLAN 10. Exit, do right, just go right down the line. VLAN 20. Switch port mode access, switch port access, VLAN 20, exit, do right. Do it for all of them. Everything's the same except for the VLAN number. VLAN 30. Next one will be 40. You can just copy and paste from Notepad too. That's a good way to do it. Makes it a little faster. It's very repetitive. VLAN 50. Last one for the Big Ten West networks. Now we're going to go to the Big Ten East. Int range FA0/1 through 24 again. Switch port mode access, switch port access VLAN 80. Exit, do right. Just go on down the line. Next one will be 90. Very sequential, very straightforward. VLAN 110. VLAN 120. Remember, this was according to the diagram, this was the Hoosiers, the Indiana Hoosiers network. Next one is Maryland, 130. And the last one is Rutgers with 140. Now we're going to go to layer 3 switch and basically do the same thing. However, there's going to be 7 per, so you have to do 7 different interfaces for the layer 3 switch instead of going from switch to switch. You're on the same switch, so you need to specify different interfaces instead of a range like we did before. And here, this was annoying, so it pops up these like messages saying there's a native VLAN mismatch, and I wish I knew how to like prevent that because it was annoying. I would be trying to type my commands and it would like pop up and ruin my right in the middle of my command, and it would cause me to get confused a little bit. So if anyone knows how to prevent that, let me know. Switch port mode access, access VLAN 10. Access VLAN does not exist, creating VLAN 10. It creates the VLANs. Now a new interface, gig 103, switch port mode access, switch port access VLAN. And here again, just pop-ups confused me and I had to redo it. Because I was supposed to say 20 there. But it just keeps popping up these messages. So I had to start over. So gig 103, switch port mode access, enter. Stupid messages pop up again. I'm just waiting for it to clear so I can type my commands. I'm going to say access, Jesus. So annoying to deal with. VLAN 20. Switch port access VLAN 20. It was hard to find my bearings with all those stupid messages popping up. But anyway, gig 104 is for VLAN 30. Now, since I did automatic connections to the switches, you notice how it's gig 104, which is VLAN 30, gig 105, VLAN 40. I could have manually picked what ports I chose, and then they would match up. So I could do gig 107 would be for VLAN 70, but I let Packet Tracer assign them automatically just to make it quicker. But it might be a good learning experience, again, to get used to dealing with all the different ports, to manually configure which port you connect to from the layer 3 switch to the layer 2 switch, from the layer 3 switch to the router. But keep in mind that the way I did it, I just had Packet Tracer automatically assign the ports. Now going to the other side, we're doing the same thing. And I believed while I was talking there that I just enabled the trunk port, which we'll do on this layer 3 switch too, so I'll mention it again. It's a very quick one little command, right? You just specify the interface and then say switch port mode trunk. Very simple. Just that connection connecting the layer 3 switch to the router. That's the trunk port. VLAN 120. And there's your int gig 101 switch port mode trunk. And now the trunk port is active. Now we're going to assign IP addresses to the routers. Enable conf t. We'll start with that top router. And then just look at our ports, make sure we get our ports right. So that one is serial 000. We need to be careful here. If we don't sign the correct IP address, it'll break everything and we won't be able to communicate the devices. Int serial 000, IP address, in this case it's 10.0.0. Actually wrong. I should have said 01. It'll tell me bad mask. So I need to enter 10.0.0.1 because that's the IP address of that NIC. There we go. Exit. Do the other interfaces. SE001. Say INT. SE0/0/1. IP address. In this case, 10.0.1.1. Or .1.1. And then your typical subnet mask. Everything's the same. Normally you just do 252 subnet mask /30 because you only have 2 devices on each network. These are all like little teeny tiny networks between 2 routers. So you can do a subnet mask of 252 in the last octet, or known as a /30 instead of a /24. But I just did /24 because I didn't want to make a mistake. Now we're on to the other router, 10.0.0.2. Now we're going to the Big Ten West router. Again, this will be a little bit different because we have sub-interfaces, but we'll do the normal one first. Int SE000, IP address 10.0.1.1.2, right? And subnet mask, type EX for exit. Now we're going to enter the new interface. It's going to be a little different. We're going to say gig 0/0 because that's the interface, but then we're going to say dot, and then the VLAN number, and the first one is 10, so we say dot 10. Notice how it says configure sub IF for sub interface. And then we say encapsulation dot 1Q and then 10. Whatever number we put first there for the first command. And then we say IP address 172.16.1.1 and then the subnet mask. Exit. Just keep going on down the line. .20 all the way up to 70 for this router. Notice how repetitive everything is. You can just hit your up arrow and then change the number from 20 to 30, 30 to 40, from .3 to .4, etc. You can use those up arrows for your command history, just like you can in command prompt on Windows or whatever. Instead of typing everything out every single time. .60. One more for the Nebraska network. 70, this VLAN 70, 172.16.7.1, of course. Now we're going to the Big Ten East side, and we're going to do the same thing. Let's first assign the IP address to the 10.0.2.2 network interface card. And then we're going to do the same thing here. Gig 00.80 from Michigan State's network, encapsulation .1Q80, IP address 172.16.8.1, and then your standard subnet mask. And then again, very repetitive. Just go on down the line and just change the numbers sequentially. .9, .10, 90, 100. Almost done. We're at 13 for whatever team that was, Maryland. And then VLAN 40.140. VLAN 140, sorry. Now we're going to do DHCP just on the two routers connected to the VLAN networks, because all those clients on the switches will get their IP addresses dynamically through that router. So we say IP service DHCP and then IP DHCP pool and then the name, in this case Illinois, that's the first VLAN. Then we say network 172.16.1, in this case .0, subnet mask, typical. And we say default router 172.16.1.1 for the Illinois network. And then for shits, we'll just do DNS server, the same IP address. Doesn't matter in this case though. Exit. Again, just repeat. You don't have to say service DHCP every time. You can just IP DHCP pool, new pool. In this case, it's Iowa.2 network. So the default router is also .2.1, etc. Minnesota. Create those pools so that each VLAN can get each client on the VLAN can get its IP address and default gateway info dynamically through that router. The router will take care of everything. Now we're on to Big Ten East. Say service DHCP. Remember, if it doesn't say router config, you need to get into the config terminal mode by saying enable and then config terminal, but we are already there in this case. Now we're just doing the same exact thing we did before, just IP DHCP pool, the name of the pool, the network, the default router, and the DNS server, just in a loop, right, for each VLAN. That's what you do. It's just repetitive loops. And you just change a little number here and there from .12 to .13. 14. .14.1. .14.1. It's that simple. Exit, do write. Now we're going to assign static IPs to all of the servers and the server network. We'll give it 172.16.02. Default gateway will be .01, of course. And then just do that for all the servers real quick. 36. Well, that was wrong. We wouldn't be able to communicate to that one because it said 172.36. So that was a mistake. All right, now we're going to enable the RIP protocol, the routing protocol, so that all the routers can communicate with everyone, transfer packets across the networks to each other, so that everything can just flow freely from one router to another, and there'll be nobody given the stiff arm like. And we're doing RIP in this, but you can do whatever protocol you want, whatever protocol your router supports. So you just say router RIP version 2 in this case, and then network, and then however many networks you have. So now we're doing now we're going to do the Big Ten East router. So we're going to have more networks because there's so many VLANs. We're going to list them all. Network 10.0.0.1.0 for that side, and then for the other side you're going to do all your VLANs one after the other. 1, 2, 3, 4, 5, 6, and 7. And then go over to Big Ten West. Same thing. Router RIP version 2. Network 10.0.2.0. Network 172.16.8.0. 9, 10, 11, 12, 13, and 14. Exit, do write to save. And that's, yeah, pretty much it. We're just going to verify by pinging stuff. So I'm on the Illinois network from their client PC, 172.16.1.2. I'm pinging the default router, success. I'm pinging the client, or I'm pinging Iowa's default router, success. I'm pinging the client on the Iowa network, success. It says request timed out for the first one, but the other one's replied, so it's all good. .5.2, I think that was Wisconsin or something. So people from Illinois' network can talk to the people from Wisconsin or whatever, I don't know. Now we're pinging stuff across all of those routers to Big Ten East, and it is working. It is replying all the way to the Michigan State VLAN from Illinois all the way over to Michigan State. That's a success. All the way over to Rutgers. We can talk to Rutgers. So that's good. It's good to see everything's working. I wasn't sure. You never know. I make a lot of mistakes, so I'm surprised it worked. Now we're gonna ping from the other side, ping from Big 10 East all the way over to Big 10 West, and it's also working. So everyone can talk to each other. They can access the servers. Um, so this uh, process was a success. I mean, we can apply this to the real world now. I mean, if you buy those 4 routers and buy the switches, that'd be a lot of money. First of all, I wish I had that much money. I could just buy 15 switches, a couple of layer 2 switches, 4 2911 routers, have a client for each network. Hey, that'd be pretty cool. And then if I did what I did here, if I actually went into those physical routers and switches, entered those commands, and everything like we just did, it would probably work. I mean, obviously there'll be other things you have to take into consideration, rather than just working from a software like Packet Tracer where it's simulated, but still pretty cool that it worked out. Um, Hopefully that worked out for you and you got through it.